Good morning, students. So today we are going to see about switched reluctance motor. So far we have seen about stepper motor. So if you see if you are comparing stepper motor with switched reluctance motor, so you can see the construction wise there is no much difference between stepper motor and switched reluctance motor. Other than that, the switched reluctance motor must need a rotor position sensor for its operation. Whereas if you are taking the consideration of stepper motor, it does not need any rotor position sensor, or even it does not need any closed loop operation. Here, switched reluctance motor, it must have a rotor position sensor for its operation. One more the basic difference between the stepper motor and switched reluctance motor is that stepper motor, it moves in discrete angular rotation, whereas switched reluctance motor, it rotates continuously. So how we can make this machine to rotate continuously with even same construction as that of a stepper motor? So while going to stepper motor, so I thought you the stepper motor, there is one type of stepper motor known as variable reluctance stepper motor. The same construction is used here also, that is the stator will be having its own independent phase and the rotor is variable reluctance, that is it is having salient pole structure and ferromagnetic material or any soft magnetic material. So here when it comes to switched reluctance motor, the same construction as that of variable reluctance stepper motor is there. The major modification is done in the design of converter or power switching circuits, semiconductor circuits. So the circuits are designed into the consideration of different four important factors. So one is, the first thing is that each phase of switched reluctance motor must be excited independently. So there should not be any phase, that any two phase that should not conduct at a time. So each phase should be excited independently. The second thing is that once the phase is completely de-energized, then the next phase should be energized. So it doesn't mean that we need to wait for complete de-energization of a phase. What the converter circuit need to have is a feedback diode, a freewheeling diode. So a freewheeling diode, so it will start its freewheel operation so that the current suppressed to zero. And the feedback diode, it ensures that whatever energy stored in that particular phase winding, it is again fed back to the supply. So this is what happening here in switched reluctance motor. So with this design consideration of power converters, we are into a continuous rotating machine with same construction as that of a stepper motor. So to be specific with this switched reluctance motor, it is expected that switched reluctance motor will occupy the e-vehicle application for the next 15 to 20 years. So even the Tesla 3 machines, so that recent advancements in e-vehicle drives, so it makes use of switched reluctance motor for its stable operation, and the controllability what we are getting when we are using switched reluctance motor is very good when compared to remaining machines. So we can easily control the speed by properly controlling the switching period of the input command pulses. So hope you understand this. So there is a difference between stepper motor and switched reluctance motor in terms of working. So the construction wise both are same. The basic difference is that the switched reluctance motor must have a rotor position sensor for its operation, whereas stepper motor can rotate continuously. A stepper motor can move in discrete steps even without any rotor position sensor. So to have this in mind, for the continuous operation of switched reluctance motor, we need many additional components, like as I said earlier, it need have good switching circuit, power semiconductor switching circuit or power converter circuit. So there are 5 basic classification of power semiconductor switching circuit for switch resistance motor. First one is asymmetrical converter or classical converter, or it is also known as two switching devices per phase circuit. The second thing is that bifilar winding. The third thing is that split link converters. Next is that n+1 semiconductor switches and diode circuits. The final one is that CDUM converter. So there are different converters so which governs that continuous operation of switch resistance motor. So the mostly used converter among this is the first one, classical converter, or two switching devices per phase converter. The meaning is that so it will be using two switches and two diodes to control one phase. So the switches is for turning on and turning off the phase, that is the ionization of phase, to control the ionization of phase. The diode is meant for feedback. So that is to recover the energy whatever stored by the phase winding, and it takes back the energy to the supply. So that is the purpose of that feedback diodes. So apart from this, so this particular switch resistance motor, so it will have its own rotor position sensor. So there are plenty of types of rotor position sensor, and where the most important two among them are photo transistor sensor and Hall effect sensor. So to be specific about photo transistor sensor, so it makes use of photo transistor. So the rotor, if you see the cross sectional area of rotor, it's about photo transistor sensor. So photo transistor rotor position sensor, it is based on the photo transistor. So do you know what is photo transistor? So the basic difference between a transistor and a phototransistor is that, so instead of base current, here in phototransistor the photons are applied, that is the light energy is applied. So how this phototransistor is used as rotor position sensor is that, if you are considering the area of cross section of machine and center point there is a shaft, so there will be a rotating sheet is placed here. 3 phototransistors are placed at 120 degree displacement. So the sheet is designed such that it will cover 2 transistors at a time. So if you are passing light over that, the sheet will cover 2 transistors, and only one phototransistor will be exposed to light. That is, it will start conduction. So when the sheet rotates, then again it will cover 2 more and leaving 1 transistor. Like that, each time it will cover only 2 transistors, whereas leaving 1 phototransistor at a time. So this the one which is being exposed to light will start conduct, and it shows what is the present position of my rotor, because this will rotate. This rotor will start rotating. So this will show us what is the present position of my rotor present position of my rotor. So if I know the present position of the rotor, I can easily decide what is the next phase to be energized if I want the machine to rotate in clockwise direction, or what is the next phase to be energized if I want the machine to rotate in anti-clockwise direction. Like that, I can easily fix. One more sensor, Hall effect sensor. So the Hall effect sensor, if you want to describe Hall effect sensor, consider a three phase axis, X, Y, Z, 3 axis. So in this 3-dimensional axis, if I am placing an semiconductor, N-type semiconductor sheet in YZ plane, if magnetic field intensity is applied in Y axis, then in Z axis electrical energy is generated, electrical potential is generated. So this is the basic principle of Hall effect. So similarly as done in phototransistor sensor, these Hall sensors are placed. So based on the rotation at different position, the magnetic field intensity will get changed, which changes the corresponding output potential. So the output potential is sensed, based on which we can decide what is the present rotation, where is the present position of my machine. So like that, this rotor position sensor will help us to identify what is the present position of the machine, and based on that we can program such that what is the next phase to be energized. And apart from this power switching devices as well as the rotor position sensor, we did one more important thing is that current controller circuits. So the current controller circuits ensures that the phase current is not increased beyond the reference value or increased beyond the control, and it will keep that within that nearby that reference band. So it should not exceed more than the reference value, or it should not come below that. So the current controller will ensure the phase current value is maintained. So with all these things coming into a connection, we will be getting a closed loop control scheme of switch reluctance motor. So this closed loop control schemes will help in establishing the application of switch reluctance motor over e-vehicles. Not only e-vehicles, many recent applications. So this is all about switch reluctance motor. Thank you.